Well, hello guys, welcome back to John's Workshop, and in this video we're moving on to part 2 of the mill upgrade. So this is my Cormac ZX7045 mill. If you've seen part 1, you'll have seen me with an International 30 taper spindle that we've spent a bit of time stripping, making good, rebuilding, new bearings, that kind of thing. If you've not seen that, go back and check that one out. And in this video we're going to move on to the next stage, which is to make the locking slash stability ring that is going to sit right at the bottom of that spindle and bolt to the underside of the head to really steady the spindle up, and probably, and still to be defined, be a change of locking mechanism or clamping mechanism for the quill when the quill's down. So, and I'm piecemealing this, I'm breaking all the rules of good engineering and just doing this totally on the fly at the minute, for the first part of this at least anyway. So this is a cast iron lump, so I've got a billet of cast iron. So the first job of that is to get that up in the lathe, and I'm going to try, I've spent the last good while grinding up a trepanning tool, so we're going to try and trepan from both sides of the billet to remove the centre core that I don't need, which will be effectively where the spindle goes through, to try and save that bit of cast iron. Now, trepanning's not for the faint-hearted. Probably second trepanning tool I've ground in the last 25 years, so not too sure how well it's going to go, and it's quite a broad, I've ground it quite wide, so we'll see how that goes. If all else fails and we can't get that to work, we will revert to old-fashioned methods and drill holes through the centre and just bore it out and waste and swarf all the material, but I am going to make every effort to trepan. So I think we've gone through most of the things on the board, you know, following the trepanning. It's just then basic turning, boring and some milling operations and drilling operations through the rest of this part, and some trial fitting with the International 30 taper spindle that I've got. So without any more waffling, we will crack on. So I will join you at the lathe just shortly when we're getting set up to get the billet in the chuck, get the trepanning tool set up, and we'll give it a go. So I've got my grey cast iron billet loaded up in the chuck. I've got my trepanning tool that I've ground up in the tool post. I've got this as a neutral tool at the minute, so I've put no chip breaker on the top to create a positive cutting action. We're going to try that. I'm not very hopeful about this. This is about 6mm, 7mm wide, so it's quite a substantial width, and I think we're going to have some problems with this potentially, but we'll give it a go. I also need to be checking my sweep as I enter to make sure I've got enough swept clearance on this outer diameter, so we're going to be looking for that. I've checked my clearance on the inside against the OD of the part, and the first thing I need to do is get rid of this rotating razor blade that's on here. So this piece, interestingly enough, I got this off eBay. The exact same thing I'm about to do with this, or hopefully, has already been done with it. So this has been trepanned from both sides out of a much bigger piece, and this is the bit that was left over, and this bit in the middle is absolutely razor sharp. So the first thing I'm going to do is see if we can get rid of that, because that's just an accident waiting to happen while that's spinning around. So we'll try to remove that first. I'll do that off camera, that's just getting rid of this, and then I'll bring you back in when we're setting the trepanning tool up in the right position and giving it a go. Not a good start. Okay, as I suspected, slightly problematic, and I kind of thought that was going to be the case. So what I've done off camera is a couple of iterations to try and make this better. We've been through a few speed ranges, no difference. So we've now started addressing the tool. I'll just spin you around and show you that. Okay, so I'm back in pointing at the tool. You'll see that I've put a positive cutting action, so I put positive rake on the cutting edge. I did that first. Still, it's cutting a lot freer, but still making a lot of noise, vibrating, and was going to break the tool. So this is a trick that I learnt from one of the guys who taught me when you're doing annular grooves like this, trepanning, if you're struggling on the lathe. So you'll see the shape that I've put into the tool there. You'll see I've ground a relief into the centre of the tool, and what that allows you to do is pitch either side, so you lose slightly more material. You know, the slug that I get left with in the centre is going to be slightly smaller, and it's a little bit more work, but you basically plunge in until you get into a full cut and it starts making a row. Then you pitch over and plunge in again, and you're just plunging the high spots, so you effectively reduce your cutting surface area by a massive amount. And so you basically dance backwards and forwards with the cross slide, plunging in, plunging in, plunging in. It removes the material really quite quickly, and that seems to be working okay. So I'll just show you a little bit of that. Alright guys, I thought I'd just show you the grind on here in case anybody's not seen that method before. So you can see the shape I've put in the end of the tool with a radius in the middle, and obviously that allows me to plunge, retract, move across and plunge the high spots, so you're reducing your width of contact. And the benefit of that is it gets me a almost 7mm wide tool, which gives me lots of strength to go in the depth that I had to go into, whilst I'm only actually taking probably 1.5, 2mm wide widths of cut with those two horns that you can see there. And that it's just a way of getting around all of that vibration and chatter, as you've seen. Still vibrates a little bit when you get to full depth, and it's at that point you back off, come back out, pitch across, and then take the high spots off again. So thought that might be a useful tip. In terms of the grind, you can see the sweep on this side that I've got on the tool for clearance of the diameter that I was trepanning, and then obviously on the inside it's just straight because the part itself is sweeping away, so you don't need the clearance on that side so much. And then if you look at it head on again, you can see it's tapered, so it's thicker at the top, thinner at the back, and that provides you clearance down each side of the tool as you get deeper into the groove. Okay, I wasn't happy with the finish that I was getting from the carbide boring bar for what we need this to be, so we've replaced that with an old Stag Major, and there'll only be people of a certain vintage that makes sense to. And this has been ground with a nice 45-degree approach and a nice radius stoned on it, and I'm getting a lovely finish in there. We're running slow at 260 RPM and with a very fine feed rate, and I'm getting a cracking finish for cast iron. It's dull, but it's a really good finish. So I'm at my final cut, I'm using balance cuts. If you want to know what that's about, go back and check out my hints and tips videos called Hitting Your Sizes. That's what I've been doing with this all the way in. So we've taken 4 cuts now, all of the same depth, and I've now got my final cut to do, which is the same depth, so the lathe should behave in exactly the same way, he says with his fingers crossed. So here we go with the final pass. Okay, so we've got our ring just as we've turned it, so all that's been done is this face, the bore and the oil retraining groove. I'm just going to put a tiny wipe of oil inside it, and we're going to give it a trial fit. Here's hoping. Well, that's a good start. It's definitely tightening up towards the bottom. It's still dropping under its own weight. There is absolutely no play on that at all, but yet it's not tight. I'm really pleased with that. That couldn't have gone any better. So next job, get this back in the lathe. We're going to hold on that internal bore with the face to the back of the chuck, and then we're going to turn the OD to our finished size, and we've probably got quite a bit of material to come off this back side because this is slightly too thick. So I will bring you back when we're doing that, but I am absolutely happy with that. That means regardless of how much play I've got going on further back up here, right where it matters, right where you're cutting, this is going to be really, really well supported. So yeah, bring you back in a minute. Okay, we've got our part loaded back in the chuck, and this is where I could ideally do with either a 6-jaw chuck or certainly some soft jaws. Got neither of those things, So, but I've got plenty of 15mm copper pipe, and that makes great soft jaw faces for a job like this. Very compliant. Get some heat on them, chuck them in some water to anneal them, and they mould to the shape of your part very easily on the jaws. So that's us set up. We're now going to get tore into facing this off to length and then turning my outside diameter finished diameter. Okay, so we've taken the front plate off the mill, and what I'm doing is looking at this bottom casting plate here for what's in the way, what's not in the way, to try and work out where I'm going to put my PCD holes into this bottom plate, where the best spacing is. So I think I've figured that out now, and while I was at this stage, before we do anything to this, I wanted to know where my start position was in terms of the slop that I've currently got in this spindle, to see whether I've actually improved anything once I've done what I'm about to do to this. So I've got a clock set up down below, so I'm just going to move the camera. So we've got our tool and we've got our clock in position. Now interestingly, when I hit the bottom of the stop, the very bottom of the spindle travel, if you watch what happens to the clock there, you can see movement there, and that's some of the just the slop in the spindle being taken out by me hitting this is the key. I'm hitting the top of the keyway in the left hand side of the spindle here. That's what's causing that movement on the clock. But if I take it off that bottom of the stop and then I pull towards me, so you can see I've got there about 0.45 of a millimetre that way, and backwards probably 0.15. So total there is 0.6 of a millimetre, which is 24 thou, something like that, movement that I can influence fairly easily. You know, I'm pulling and pushing, but I'm not really trying to bend the thing out of shape. So I've got 24, 25, 30 thou, something like that movement. 0.4, 0.5, 0.6, 0.7 of a millimetre appreciably that I can measure there. Another interesting test, if I just zero out, so that's in an unlocked state. If I now lock the spindle with the lock, I'm actually getting about 3 thou or 0.07 movement with that lock. I'm at full extension of the quill with that much slop in the quill. I'm quite happy with that. I'm following what Stefan Gotterswind has done largely with what I'm doing here. Now Stefan's got rid of the clamp that that I've got in, and he's incorporated a new clamp into the stability ring. Based on that amount of movement, clamping of the spindle is not my biggest issue. My biggest issue is the amount of slop in it. So from a design perspective, I am not going to put an additional clamping into this ring. I'm just going to purely use this for stability. That makes the manufacture simpler. So next thing I'm going to do is set up my ring now and pop my pattern of holes in. Now I've done my assessment, so I'll bring you back when we're doing that. Okay, so we're ready to do our PCD holes, so we've got 6 holes on 105mm PCD. I've programmed that into my DRO, and just to save any silly mistakes I've been round with a Sharpie marker in the chuck and just checked my positions, so I'm still getting used to using this DRO. So I'm happy that we've got that programmed in correctly, looking at where the dots are, so we're going to crack on. Okay, so we've got our part now in the other station on the mill, in the vise, and we're just going to mill a small flat in between these 2 holes, just eye-sighted level, and then we're going to drill a small hole all the way through into the bore for the oil groove, and then drill and tap M6 for a zerk fitting to go in. So I've already touched on the back. I've wound my cutter across in the y-axis to the right point, so we're just going to touch off and mill a small flat on the top face. Well, there we go, that gets us to the end of this episode. So that's our spindle stability or stiffening ring. Not really made my mind up what we're going to call that. I'll lay an egg on that before I put the video up, so hopefully it makes sense to other people. So that's the second in the mill upgrade series, or the mill head upgrade series. So you've seen the stability ring be made. You know, that's really beefy. That is really beefy ring, and I'm probably going to get some comments about how thick that is and how much quill motion I'm going to lose. I've got a plan for that to mean that I don't lose as much quill motion as you might think, and that's going to be in a very exciting episode, which will be part 3, and I'm looking forward to that one. So that kind of brings us to the end of this video. I hope the trepanning tips were helpful for people who struggled with trepanning or face grooving or whatever you want to call it. I mean, trepanning's the proper name, but annular grooves, face grooves can be tricky, especially on small lathes in a home workshop. So next week we'll be back with, I'm not sure yet, I'm probably going to intersperse the mill head upgrade now. I've got those first 2 videos done with something a bit different, so we might be either dropping back onto the shaper refurb or maybe a hints and tips video. So I've got a few things in the can for that, so I'll decide what we do next week slightly differently. That's a bit of a spoiler. So thank you all very much for watching. I hope you're enjoying the mill upgrade series. Thank you to the subscribers and the new subscribers that have come along, and we will catch you all very soon on another video when we'll be making something else.